How's it going, ladies and gentlemen? Mr. Donnie here again, taking a look at 16.7 stuff, weak bases. So our objectives are as follows. Explain what makes a weak base weak, and use the KB to determine pH and concentration and vice versa. So going from pH to concentration or concentration to pH. All right, so weak bases. A weak base is a compound that removes a proton from a water molecule, making a conjugate acid. All right, so the conjugate acid is a stronger acid. So if we're taking a look here, NH3 is going to be my base, and it's going to steal a proton from water. Boom. So it's taking that proton from water, and it becomes a stronger conjugate acid. So now that it's NH4 plus, it's a stronger conjugate acid. All right, so types of weak bases. So they can be electron donators. Basically, they can have unshared electrons that can donate electrons to bond with an H plus. Or, well, for example, like in the last thing that we just looked at, NH3 had this lone pair of electrons that it was able to take and give to an H plus and make a bond with it, giving it NH4 plus and OH minus. All right, they can also be anions of weak acids. So, for example, HF is a weak acid, which means that F minus will be a stronger base. So let's say I had a salt like sodium fluoride and I added it to water. Well, what's going to happen is the sodium and the fluoride are going to break apart. Right now I got this fluoride ion, and that fluoride ion is the conjugate of a weak acid, meaning that it is a strong base. And it will steal a hydrogen from the water to make HF. So those are two types of weak bases. So what's KB? All right, so KB is just the equilibrium constant. Again, if it's K, it's an equilibrium constant, and if there's a letter after it, it's telling you something about it. The B is telling you that it's for a base. All right, so this is our generic equation. I got a weak base that's aqueous. I put it in some water, and it will react with water to give me a conjugate acid and a hydroxide ion. Right, so it's like this that's going on. I got a fluoride ion. Okay, KB for this will be Hb plus times OH minus over B. And notice that the water drops out because it's a pure liquid. So it drops out of the K expression. For this scenario, we got fluoride. It's stealing a hydrogen from the water. So for this reaction, the KB would be the concentration of HF, which is the product that we made, times the concentration of OH minus, which is another product that we made, all over the concentration of the fluoride ion. Cool. So question, what is the OH concentration in a 0.2 molar NH3 solution? And it tells me the KB is this number. So I know that NH3 is going to be a weak base, and its KB is this. So I probably would start with writing out the equation for it, so I know what my KB is going to look like. So I know that if NH3 is my base, it's stealing a hydrogen from water, so I'm going to end up with NH4 plus and OH minus. So that tells me that my KB is going to equal the concentration of NH4 plus times the concentration of OH minus all over the concentration of NH3. Remember that the H2O is a liquid, so it's going to drop out of my KB expression. So now I'm kind of doing an icebox thing going here. I know NH3 I started with 0.2 molar, right? So 0.20. Water, we can ignore it, and we started with no ammonia and no hydroxide. How did it change? Well, I lost a certain amount of NH3 and I gained a certain amount of NH4 and OH minus. Notice all the coefficients are 1, so it's just X. There's no 2X or anything to worry about. So at equilibrium, I get 0.20 minus X for NH3, and I get X for NH4 plus and X for OH minus. Now I got to solve for X because that's what the problem's asking me to do. So I know that my KB expression is going to equal X times X over 0.20 minus X. And now I'm going to do a little trick that I think I told you guys about before. I'm going to assume that this still equals 0.20. I'm going to assume that X is going to be a really, really tiny number, and then I'll go back and check to see if I was allowed to do that. So that's going to tell me that I end up with X squared over 0.20 has to equal my KB. So now I do some algebra, and I get X is going to equal the square root of 0.20 0.20 times my Kb, which is given up here in the problem. And I'm going to solve for that. I'm going to punch some numbers into a calculator. Beep, bop, beep, bop, boop. And I get 0.0019. So now I want to check, hey, was that assumption okay to do? And I do that by looking at, all right, well, what is 0.20 minus 0.0019? Well, if I round that to sig figs, it's still going to be 0.20, so it's okay that I did that. So my final answer is going to be 0.0019 molar, right? So now let's say the question wanted to know what the pH was. Well, now that I got the OH minus concentration, I can do that relatively easily, a couple of ways. Whoops, erase. My preferred way would probably be to calculate what the pOH is. So I know that pOH is going to equal the negative log of the OH minus concentration, which is also going to have to equal 14 minus the pH, right? So if I want pH, it's going to be 14 minus the pOH, which is going to equal 14 minus the negative log of 0.0019. And I am going to get an answer as soon as I punch it into my handy dandy calculator. All right, 14. All right, so log, oops, sorry. I should probably edit this out, but I don't think I'm gonna. 0.0019 equals that. So now I gotta do 14 minus that. So 14 minus 2.72. I'm just gonna write that out. And I'm going to get 11.28 as my pH, which makes sense that it's basic because I'm adding a base. All right, cool. So to summarize, weak bases only partially ionize or react with water to create OH minus, and they do that by removing a proton. They can either react with water directly or dissociate into ions that will react with water and remove a proton. And Kb is the equilibrium constant for a weak base. That's it. Hope you found that helpful. I'll see you in class. Bring questions. Goodbye.